Hello and welcome to this part where we're going to solve the Science Paper 1 GCE 2020 examination paper. So we're going to revise this paper so that we prepare for the paper 1 science examination. That is it could be GCE, it could be internal, it doesn't really matter, it's all science. So Science Paper 1 2020, what you bring with is a calculator and graph paper probably will be provided. Instructions are that you have about 3 sections in the paper: A, B, and C. You answer 20 questions from section A, that would be multiple choice. The section B, you answer questions that is in the answers provided. In section C, you answer any 2 questions. So what I really my advice on this one is on time. That is, you definitely need to put into consideration the amount of time that you allocate to a specific question, because you just have got 2 hours. So you should allocate specific time to a specific question. If you have 20 questions, you can probably allocate 2 or 1 minute to a question for multiple choice, and so that you should probably finish in time or on time. So this question paper, we already have part 1 of the 2020 question paper, and if you didn't see the video, I'll probably put the link in the description or somewhere on this video so that you can watch the part 1. So we did question 1, 2, 3, 4 and question 5 in part 1 of the video. That is for the GCE paper 1 revision. So we're going to start on paper 2 on question 6 without wasting much time. So question 6 had the question said: a 60 Newton object is placed on a uniform bar that was balanced at its midpoint as shown in the diagram below. So we have this setup here. Which of the following will rebalance the beam? Okay, so we have got a 60 Newton object here which is placed on a uniform bar, and this is the uniform bar they're talking about, I believe, at its midpoint as shown in the diagram below. And then from here, so for you to understand this question or to solve this question, you need to understand what we call the law of moments. The law of moments, which says that the total clockwise moments should be equal to the total anti-clockwise moments. Now for a moment, you know that when it comes to moment, the turning effect or torque moment is equal to the force times the distance. That is the moment. So the moments have to balance. That is, the clockwise moment and the anti-clockwise moment have to balance if this beam was to be in balance. So what is the anti-clockwise moments? Are the moments that will make this to turn to the in the anti-clockwise way. I think this is an anti-clockwise moment. This force will make this turn anti-clockwise. So the anti-clockwise, so we'll say anti-clockwise here, anti-clockwise should be equal to the clockwise. And so what do we have for the anti-clockwise? We have 60 newtons force times the perpendicular distance from the pivot. That is 60 times 30 centimeters. That will give you that is 600 times 3, that is 18, which is 1,800, right? So it will be 1,800. So we're using centimeters, so it will be newtons centimeters. Okay, they are not the formula as a unit, but that is what we have. So we have centimeters here. So which of the following will balance the beam? So the clockwise moment here, the anti-clockwise moment here is 60 times 30, which of course will give you 1800 as the moment. So the clockwise moment, which should balance the beam, should also give you 1800. So which one is it? So right here, if you can see, we have a 30 newtons times 30 newtons, that is the force. We need to multiply with the distance to the left of the pivot. So which is the left of the to the left of the pivot? Okay, so magnitude of force 30 newtons, 60 centimeters to the left of the pivot. Okay, so now we are talking about left and right here. So I assume the left of the pivot is this side. This is the left of the pivot. This is the right of the pivot, because my right hand side is, when I'm looking at the paper, this is my right. My right will be this side. So I assume this will be the right of the pivot and this will be the left of the pivot. So to the where we need the weight, we can't put the weight here. That would be wrong, because it will definitely just top over in 4. So we can't put it there. So I'll say we can put it to the left. So where is the left? That would be wrong. So I'll say to the right. So somewhere here we should put an equal weight somewhere there, which should be 30 newtons as well. Which should be 30 newtons, not an equal weight, but 30 newtons, and it should have a distance to compensate for the 60 newtons. This is 30 newtons, therefore it should have a distance probably over, okay, so which will give me if I have 30 newtons here of the force as my force, so my weight times the distance from here to there, because I need it to be 1800, but from here to there the distance should be 60 centimeters. And you can see here that B actually B qualifies. We have 60, 30 times 60 here, so the answer here will be B. So here, if you multiply 90 times 20, it will also give you 1800, but this to the left of the pivot, which of course I assume here that this is the left of the pivot, so it won't make sense. So you need it on this side, to the right of the pivot, should guess. Okay, so anyway, left, right, but you need it here so that it can be 30 times 60. 30 times 60. B will make the will work. The motor is used to pull a 10 kilogram box along a 5 meter long incline to the top of the decline as shown in the diagram below. Okay, so ignoring all friction forces, determine the work done against gravity in pulling the box from the foot of the incline to the top of the decline. So what I would advise is, as you're reading these questions for the first time, probably you're just getting a rough idea, I would advise that you read a question 3 times before you start answering the question. So why is that? Because you need to understand, first of all, you need to get a rough idea of the question. That is the first reading. So I just read through like a motor is used to pull a 10 kilogram box along, not really trying to answer the question, but just reading to get the idea. And then the second part, that you read the question to extract the data. You will now read to understand what this thing is talking about. So let's read for the second time. A motor is used to pull a 10 kilogram box. So this is a 10 kilogram box. So we know that the mass, we have mass, so you can say data here. You can collect your data. Most students know this, so you say you have got 10 kilogram, right? So 10 kilogram data, 10 kilogram box, and along a 5 meter long incline to the top of the decline. So from here to there is 5 meters. Okay, so we have got a slanting height of 5 meters. Okay, and then ignore all frictional forces. Determine the work done against gravity in pulling the box from the foot of the incline to the top of the decline. So they want us to find the work done. So we don't know work, but we have a height of 5 meters, and we also have a height. So height 1 is 5 meters, and height 2, which is the vertical height, is 4 meters. So which one do we use? So before we talk about how do we find work? So work is equal to, we say work is equal to force times distance in the direction of force, times distance in the direction of force. So the work here done is equal to the force. Well, what is the force? So the force on a particular object is its weight. So this is work, but the force of a particular object is its weight. So what is the weight here? Weight is equal to the mass, which is 10 times, let me just write the formula for weight. Weight is equal to mass times g, and we have the weight of this object is 10, its mass, which is 10, times g, which is the gravitational field strength or force, which is 10 newtons per kilogram. So by 10, so when you multiply 10 by 10, we have 100. So now this is the weight, which is the force, so it is 100 newtons. Okay, that is the weight of the box, 100 newtons. Now if you want to find the work, you need to multiply the weight of the box, which is the force of the box, times the distance it is moved. So remember, work is the force done, the force times distance in the direction of the force. So we have got 100 as the force times, what is the distance? So the distance here we are considering is the vertical distance, because we can't use the distance from here to there. Okay, the actual distance moved by this box here is from here all the way to the top there. Okay, so this is the distance we want, not the vertical one. So we are going to multiply 100 times, not the slanting one, we want the vertical one. So multiply by 4 meters and we get 400. Now work is measured in joules, so that is 400 joules. That is we're talking about a calculator J, so 400 joules. So you come here and we see the answer should be C, 400 joules. So that should be our answer. Let's go to the next part. A girl whose mass is 50 kilograms climbs a ladder of height 8 meters in 10 seconds. What is the power developed by the girl? Okay, so sometimes in physics it helps to even draw things so that you can just try to understand. So we have a girl. Okay, we don't say we should start drawing a girl, but just sketch what's happening. A girl climbs a ladder of height. So if this is a ladder of 8 meters, okay, and the girl climbs this ladder in 10 seconds, okay, and the weight of the mass of the girl is 50 kilograms, right? 50 kilograms. What is the power developed by the girl? So what is the power? So first of all, we need to understand what power is. So power is the rate of doing work. Okay, it's the rate of doing work. So power is equals to work divided by time. How much work you do in a specific unit, in a particular in a unit of time, so to say. So here we need to find work for us to solve this question. What is the work done by this girl? So the girl is 50 kilograms, has got a mass of 50 kilograms. So we need, just like in the previous part, we need to find the work. So work, we need to find the mass. So work is equal to force times distance. So we need to find the mass. We've already been given the mass, but we need to find the weight. So the force here is the weight. The force is the weight, which is equal to her mass times the gravitational field strength, which is G. We already solved the formula for finding weight. We said it's weight is equal to mg. So her mass times gravitational field strength. So this will give us 500 Newton as her weight. That is 500 Newton. So she climbs a height of 8 meters. So what is work done here? So work done is equal to work. Remember, we said work is equal to force times the distance. So her force, the force is the 500 newtons times the 8 meters. So we're going to, allow me to put it somewhere on this part because I'm running out of space. So her work is equal to force, which is 500, times the distance she ran, or she had to climb, 8 meters, which gives us that is 4,000 joules. Okay, that is 4,000 joules, because 500 times 8, that gives us 4,000. So power is equal to her work, which was 4,000, divided by the time it took for her to carry out this work, which is 10 seconds. Just 10. So we divide 10 into 4,000, you just cancel 1 0, and that will give you 400. And power is measured in watts, so it's 400 watts. So we come here, the answer should be B, 400 watts. Okay, so because of time, we'll try to run as fast as we can. We can't definitely want to cover as much questions as we can. That's the idea. So we will be running, I will be trying to explain a little bit faster. If it is fast, you can pause the video, you can replay it again. So question 9, a machine with a velocity ratio of 6 requires 800 joules of work to raise a load of 60 kilograms to a vertical distance of 1 meter. Find the efficiency of the machine. So let's find it. So efficiency is defined as the ratio of useful work done by the machine to the work put into the machine, or it's a ratio of the work done by the machine to the total work put into the machine. So that is efficiency. So efficiency is equal to the work done by the machine divided by the work put into the machine. So another formula says that efficiency is equals to the mechanical advantage. Since we're talking about the question talks about the velocity ratio of 6 requires 800 joules of work to raise a load of 600 kilograms through a vertical distance of 1 meter. Find the efficiency of the machine. The mechanical advantage is divided by the velocity ratio, okay, times 100%. So this is the formula for another way that we can write the efficiency formula, or another way we can write is that efficiency is equals to the work output by the machine divided by the work put into the machine multiplied by 100%. That is efficiency. So as we're trying to solve efficiency, you can use any of these formulas. So let's see, here we have got a machine with a velocity ratio of 6. So we can, our data, we can say we have got a velocity ratio of 6, and then it requires 800 joules of work. Okay, 800 joules of work, that is the amount of work we put into this machine is 800. Okay, so input work, so you can say the input is 800 joules, right? 800 joules as the input to raise a load. So the output is going to raise a load of 60 kilograms through a vertical distance of 1 meter. So we have got a work done is going to raise a load of 60 kilograms. So we've talked a lot about how to find work. So if you transfer a load of 60 kilograms, which has got a mass of 60 kilograms, which has got a weight of 60 times 10, that is 600, through a vertical distance of 1 meter. So that means times 1 meter, your work is 600 times 10, which is 660 times 10, which is 600 newtons, right? 600 newtons, that is for the weight. Now you multiply this times the distance, which was 1, so it means the work you've done is 600 joules. Okay, so this machine has been given 800 joules to do a work worthy of 600 joules. So it's like a business. Like you put in 800 and it gives out it gives out 600 whatever, if you scratch out dollars. So now find what is the efficiency of that business, if you can say in those terms for entrepreneurs maybe to understand. So what is the efficiency of that business? So it's the same here. So what is the efficiency of, so we have a velocity ratio. So let's see in how we can use this. So the efficiency would be we are dividing the 600 divided by 600 calculator, then we divide this by 800. So because we say ratio, right? The efficiency is a ratio, so we get 0.7 we get 0.75 as the ratio. So efficiency simply is a ratio of the output divided by the input. Okay, output work divided by the input work. So we have 0.75. Sometimes it could be in percentages that you multiply by 100%, so it will be 75%. Okay, so this business has got an efficiency of, this machine has got an efficiency of 0.75 or 75%. Okay, it depends with which one you want to. Alright, so let's go to the second part. The diagram below shows the length of mercury threads at the ice and steam points. I don't know, I'm thinking about ice cream right now. Okay, the diagram below shows the length of mercury threads at the ice and steam points. Somebody needs to take me for ice cream. What will be the temperature if the length of the mercury thread is 25 millimeters? Okay, so question number 10, the way I'll do it, it shows the length of mercury threads at the ice and steam points. So I'll find the difference of the mercury threads. First we have got at ice point was 5 meters, then it goes all the way to steam point at 15 meters. So we find the thread difference. So the difference